I tell you. Hey, how are you?
Can you hear me?
Yeah, I can hear you. Can you hear me? Can you hear me? No, crying out loud. I'm calling you. It's you.
Hello?
Hello?
Can you hear me?
Yeah, I can hear you. Let me. I haven't set it up on this thing yet, so.
Oh, okay. Let me, I'll put mute on my phone so that way we record it on the computer.
Okay. Let me put it on silent on my end. Is that silent?
Can you hear me?
Yeah, I can hear you.
Okay.
Can you hear me?
Yeah, yeah. I can hear you through the phone. You can hear me through the computer. So
Yeah, we're good.
we'll get it recorded one way or another. Okay, let's see. I did not do very well on this quiz.
I haven't finished it yet. My stupid computer is whatever.
Being special?
Yes, very special. Give me just a second to pull it up. If I can get this to pull up. For some reason, Chrome had issues. Let's see here. Do you have, hold on. Do you have, where's the, I have some on there saying I don't know how to use it.
You have the what?
There we go. Can you put your phone so I can hear you through the phone?
Yeah, but then, so the only thing that I'm thinking is then we won't be able to pick it up on the computer. What's that?
Can you hear me, Parker?
Yeah, can you hear me? Hey, can you hear me?
Yeah?
Yeah, can you hear me?
Yeah, I can hear you.
Okay, could you not hear me through the computer?
I'm disconnected from you now.
Oh, okay.
Oh gosh, what a mess.
Do you have better? Well, you know what? That's okay. We'll just keep you on the phone, and I'll just record this, and then that way, Brother Paulson can know you're in the meeting.
All right. So
and
let
then
me pull up my quiz. I wasn't quite finished with it yet, so but it's the map stuff, right?
The what's that?
The map?
Yeah.
Okay, cool.
Oh yeah. So I took it earlier, the one round, and I can tell you the ones I got right, and then I don't know. Well, I just had to figure out the ones I got wrong. Hopefully you get them right.
Okay, let's see here if I can get it to come up. Because Trump is having issues.
It's being special.
It's been special all day. I have my econ class. We meet in the morning at it's 6:30 my time.
Oh, nice.
Yeah, and it was super special this morning. Like my whole computer was pretty much frozen up. So I was like, that's awesome.
Oh, that's a problem.
Yeah. Let's see. We are looking for the lesson 16 group meeting quiz, right?
Yep.
Okay, in progress. Continue quiz. I actually just got off with Connor going over the test, so.
Oh, nice.
Yeah, which is super helpful.
Yeah, that's
actually.
good.
Okay, so let's see. I apparently didn't get that far in the quiz. Good grief. Okay, so let's see. 1, 2, 3. Okay, number 3, you got each slice represents a category.
Number 3, yep.
Okay, number 4, the only difference between a bar chart and Pareto is the Pareto is largest to smallest.
Yep.
And then number 5 is true proportion.
Yep.
And then 6 is the sample size, correct?
Yep.
Okay, so then I didn't actually get to any of the math because it didn't make any sense to me. This P equals 1/4. What is the smallest n that satisfies the requirement?
Yeah, so I didn't understand. So let's see, I got 8, and I just took the P from above, and I just put that in. So I just did 0.4.
Well, what about this though? Do we see this is larger or equal to 10 and n 1 minus p is greater or whatever to 10? So n times p. Did you get that right though, number 7?
Yeah, I got number 7 right. Number 7, number 7's 40, I'm sorry.
Okay.
And the way I got that was
go ahead.
Yeah, I did 1/4 times I just did some like basic algebra basically.
Right, because it goes up with that equation though. That equation up there.
Yeah. I did 1/4 times 40, and that's 10 is greater than or equal to 10. So I was like, okay, that'll work.
Right.
So that one was easy. It was just basic algebra.
Okay, so 24.4. Did I miss this? Okay, so what is the mean of hat P?
Yeah, and I said 0.4 because I just took the value from above, and that was correct.
Okay. See, what is the standard deviation of hat P, which is that the P minus the parentheses P times 1 minus P? That equation is?
It is, yeah, it's square root of P times 1 minus P divided by N. And you'll get 0.1.
For each batting average, number 10.
I did not get number 10 right.
Okay, so her batting average is 300 or whatever. We want to determine the probability she'll get more than 35 hits in her next 100 at-bats. So N is equal to 100 and P is equal to 0.3.
And I
so
put...
the sample size is 100, the P is 0.3, and then 35 is... So what is that equation again then? Let's look at what that equation is.
Oh, I'm an idiot. I think it's this, Cassandra. I'm dumb. It's oh, okay. I think I know what it is. I think it's 0.35 minus 0.3 divided by, or no, it's just 0.35 because 35 out of 100 would be the same as 0.35.
Right.
So it's, I think number 10 is 0.35.
You think it's 0.35?
Yeah, and if you don't mind, what we'll do is we'll have you submit the answers and check them, and then I'll have one more. And then does that make sense? So that way we're kind of.
Yeah. No. Totally fine with me.
Okay. Yeah, I think it's 0.1. I think it's 0.35 though because I didn't see this earlier. She will get more than 35 hits in her next 100 at bats. So I think you just use that 35.
Okay. If not, I can go back and look for whatever that equation was.
Yeah, the equation for finding convert standardize the values of p using the standard normal variable. That one is z equals p hat minus p divided by square root of p times 1 minus p over n.
Say that
again. Let's see. How can it's the easiest way to show you?
A little bit slower. I just couldn't hear you. You have to go a little slower.
So z equals hat p minus p.
Hey, stop that. Stop that. Hey, you go lay down. So z equals hat p
minus p divided by the square root of p times 1 minus p.
P times 1 minus p over
n.
Okay, so 100, and then we have p, which is 0.3. So let's see. Do we have z? Z equal to hat p.
No, we'd have to solve for z later.
Divided by 0.3 times. Stop, Bronx. Stop. Go. Hey, go lay down. I'm gonna lock you in your room. You go to bed right now. Go. Hold on just a second. I'll take you with me. I got the dog will contain. Hey, come here. Get over here. Go. Go. Go to bed. Right now. Go lay down. Sorry about that.
Oh, you're good.
Bless his heart. We'll sit there and defend any noise, but okay. So, so how can we can't solve for hat p if we don't know, we have to have at least one other thing.
No, that's what I'm saying. I think hat p is just in the information in the problem.
Oh.
The 35 hits in her next 100 bats, that's 0.35.
0.35? Okay.
Yeah.
So 0.35 minus 0.3 would be 0.05 divided by.
Well, are you trying to do number 11 or 12?
0.7 divided by the square root, or that's all square root though. That's all square root, right? Of 100?
Yeah.
So 0.21 divided by 100, square root of that. No, that's not right. It's 1 divided by, it'd be 1 divided by 100, so whatever the square root of 1 divided by 100 is. I think I'm making it harder than it needs to be to actually do it longhand on the calculator.
Yeah.
You're like, yeah, I would agree.
Well, I got lost. I don't know what you're trying to do.
Solve for, what are we solving for? We're solving for the standard deviation.
So for the standard deviation, all you have to do is p, you just take the square root of p parenthesis 1 minus p close parenthesis divided by n.
Oh, okay. So then that's 0.3 times 0.7, which gives you 0.21 divided by 100 and the square root of that, correct?
Yeah.
Let's see. We go square root, let's clear this out. We go square root 0.21 divided by 100. Get the square root? No, that doesn't work. That's the square root of that entire thing, though. Well, about 0.21 divided by 100 is equal to 0.0021. So we get the square root of that. .0458.
I got 0.046.
So 0.046. Did you get that one correct?
Yeah.
Okay, yeah. 0.046. Because you round it right 3 decimal places. Okay. And then the Z-score would be, did you get that one right too, the Z-score?
I did not, but I just resolved it. And basically what you do is that same equation we use for the standard deviation, you just divide 0.35. You divide 0.35 minus 0.3 divided by that same equation we were just using.
Minus 0.3.
And that gives us our Z-score.
Okay, 0.046, right? That is what the...
Yeah.
So it's 0.05 divided by 0.046, I would assume.
Yeah.
0.05 divided by 0.046 is equal to 1.087.
I got 1.091.
Did you get that one right?
No, that's the answer I just got right now.
Okay, you said you got 1.091?
Yeah.
1.087. Okay, we'll use your number.
Okay.
1.091, and then we'll see.
Okay.
That sounds good.
No,
okay, so probability Brittany gets at least 35 hits in her next 100 bats. So the probability...
We just enter that Z-score into that applet. And I get 0.8624, so 0.862.
Okay. Into which applet?
That one that we've been using online.
Huh?
The probability applet.
Okay, hold on, let me pull that up. I don't know why my computer's all frozen up. And you put that in the area, right?
You take the Z-score we just found, and since we're trying to find at least, then we select the left and the middle, and we just put it in the Z-score.
But we don't select the right.
Yeah, don't select the right.
And we put it in. Hold on, let me go back down. What number do we put in there?
The Z-score we just found in number 12.
So 1.091?
Yep.
And did we put that on the right side into the positive one?
Yeah, the positive stuff goes on that right box.
And then we take the area, correct? That gives us the area?
Yeah, and then it'll give us the area up top.
So 0.8624?
Yep.
Okay, there you go. Okay, so true proportion of people, Canada is 0.52. 2,000 people are surveyed. The probability that the rest of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. So the standard deviation of HAP-P is it's just the square root of P times 1 minus P divided by N, correct?
Uh-huh.
Okay, did you get all that right?
I got 14 right, and now I think I just realized what I did wrong.
Well,
for
here,
15.
14, and let me go to 15 with you.
Okay. So do you want me to explain? You know how we do 14, right? It's just that same equation we've been using.
Yeah.
Okay. So then all I'm going to do for this one is getting less than 50%. I'm just going to do 0.5 minus 0.52 and divide it by what we got in 14.
Okay, wait a minute. Hold on. Wait a minute. Let me do 14 really fast so that I have an answer there.
Okay.
Let's see. P, so 0.52. So 0.52 times 0.48 divided by 2,000. So 0.52 times 0.48 equal to divided by 2,000. So, and then we want the square root of that, which is 0.011. 0.011.
Yep.
Okay, 0.011. And then save that. And then 615. So then the z-score, the z-score is equal to okay, the z-score is equal to hat p minus p over that 0.011, correct?
Because that's just a standard deviation, so we don't have to do that part again.
Right. So then that's going to be, so we're just solving for
the z-score.
Did I miss hat p then again? No, I'm missing something. I'm so confused.
So this
we don't have hat p though.
We don't need hat p. Oh yeah, we do have it. It's in the problem. It's the 50%, which is 0.5.
Oh, less than 50%. Okay, so it's the 0.5.
Yeah.
Okay, so 0.5. So 0.5 minus 0.52, which is I think 0.08. So 0.5 minus 0.52, which is 0.02, negative 0.02, divided by 0.011 is equal to negative 1.818.
Yep, that's what I got.
Okay, now do we plug that in? No, that is the z-score, right?
That's the z-score, yep.
Okay. All right. So negative 1. What was the answer again? 1.818.
Yep.
Okay, 1.818. Okay, what is the probability the survey results will show the candidate is losing, even though the true p is equal to 0.52?
So I just took that z-score we just found and just plugged it in. I think into that applet.
We're doing everything to the left because it's less than. It's less than. So that was what, negative 1.818?
Yeah.
So what is that then? 0.0345 or 0.035?
Yep. Yeah.
Okay.
0.035. Yeah.
Oh, good grief! Where did my? Oh, there it is. I lost my whole quiz for a second. Okay, 0.035. Correct.
Yep, that's what I got.
Okay, let me submit this and make sure. Let me make sure everything. Okay. Okay, let me look through this really quickly. So that's correct, that's correct, that's correct, that's correct, that's correct. Okay, so number 13 is incorrect.
Okay.
So that was 0.862 is not correct.
Okay.
So hold on, let me see if everything else is correct. Okay, so yeah, so just number 13 is incorrect.
Okay, and that's the one that you got a different answer on.
No, it's not.
Oh yeah, what the heck?
No, that was 12. 12, you got 1.091, and that is correct. So, okay.
So do you think we shaved the...
Bernie gets 35 hits at her next 100 at bat.
Do you think that it is... that we just fill the right side?
So 35 hits is only... what was our... It was less than 50%.
Oh,
right?
Cassandra,
So
it's
gonna be to
the
the left.
we have to do the right.
So we put in 1.091, correct?
Yeah, but the shading on the blue, we're supposed to select the right side of it, not the left in the middle.
Not the left in the middle. We're supposed to select. I don't understand why.
Because it's at least. So it's saying, hey, we'll get this and possibly more. So the probability they're saying is just, hey, like you'll get this at least and possibly more as well. So since it's at least, then we have to have that line and then the possibility of getting extra in there. With the way we had it before of selecting just the middle and the left, it was just up to that. It wasn't enough. Does that make sense?
So what are we shading then? The middle and the right, or just the right?
Just the right.
All the way to the right, like past the two red lines?
Yep.
Which gives you 0.1376, so 0.138?
Yeah.
Okay.
So let me try that.
Do you want me to try it? I don't really care. So
No, that's nice of you, but no, it's okay. Okay, that's what it was. We shaded it wrong. It's 0.138.
So it's 0.138?
Yep.
Okay, you just resubmitted it?
Yep. And I'm looking at 18 out of 18.
Okay, let me pull the quizzes up, or let me do this again then.
Yep, I got you. I'm gonna hang up the conference call though on the computer because we're covered this. So.
Okay.
But I won't hang up the phone. Don't worry.
Let's see here. Let me find.